Hello friends, welcome to Philo Agents, the interactive simulation where agentic AI meets philosophy. You will get the chance to speak, to chat with different historical figures from Ada Lovelace, Leibniz, Descartes, Dennett, Turing, Plato, Socrates, etc. Each one of the characters of the NPCs that you see right now are actually AI agents pretending to be these historical figures. And the way that you interact with them is pretty simple, as I will show you. So let's move Sophia. Sophia is the main character, the one that you will control. And let's start talking with Turing, for example. So let's press the space button and hello, my name is Miguel. I'm Alan Turing. I'm intrigued by the notion of thinking machines. Can a machine truly think or just mimic human thought? So each one of these philosophers is going to ask you about AI-related questions. Socrates, for example, will ask about the ethics of AI. Turing will ask about the Turing test, Turing machines. So what I want to show you today, what I want to explain today, is how you can build these NPCs with a LangGraph workflow. Or to rephrase this, how you can build the brain of these AI, of these intelligent NPCs using LangGraph as the agentic framework. Okay, so this is Turing saying his stuff. I think he asked about if machines can truly think. So let's say, I don't know, but I've heard of the Turing machine. Turing machine, my theoretical model for computation. Okay, so now if we go to comment to OPIC, this is the tool that we are going to use for all the observability and evaluation on observation of agents, and we are going to cover this in lesson 5, but I just want to give you a very quick glimpse of the appearance of the LangGraph workflow that we are going to use. By the way, here in OPIC you have a lot of amazing information, like the different prompts that you're going to use, correctly version. For example, here you have the philosopher character card. This is the template prompt that is going to define the system prompt for each one of the philosophers, like the personality. We also have data sets in case we want to use a data set for evaluation, which in fact we are going to do in future lessons. And here inside projects, if you click Philo Agents, you will see that we have these traces. This is really interesting for what I want to show you right now. Click here, for example, and you can see that this is the last message that is sent to Turing, right? Like, I don't know, but I've heard of the Turing machine. And after that, Turing will respond with the Turing machine, my theoretical model for computation, but I've also proposed blah, 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 all right? This is the traces, but what I want to show you is the agent graph, because this is exactly how the brain of this Philo agent, Turing Philo agent, actually works. We will see this in LangGraph Studio, but just to let you know that today's video is going to be covering each one of the nodes, of the edges, and the agentic graph that maybe you are not seeing right now, but I will explain it to you. The agentic graph that takes place in this LangGraph workflow. All right? Okay, so before we begin, I just want to give you a very quick reminder, and this reminder is that you have all the code already available inside the Philo Agents course, all right? You can go here and you can follow all the different instructions that we have put in the install and usage markdown. And in there, if you follow each one of these steps, you will have your own version of Philo Agents running locally on your machine. So yeah, that's exactly what I have done. I've created all the environment variables, etc. And after you run this command, this make infrastructure app, you will be able to start playing with the game as I did in here. All right, perfect. So let's go then to the repository, not to the repository, to the IDE, to Cursor. And in here, I just want to explain to you some of the directories and of the folders we are going to cover. So first of all, in terms of the UI that you have seen when you go to one of these agent NPCs and you start talking, what's going to happen here is that when I press the space button and I start typing my question to the philosopher, so you're going to interact with one of several, not one, several classes inside the Philo Agents UI. the user interface that we have implemented using Phaser. Phaser is the JavaScript framework for browser games that we have used for this project. So the classes that interest me the most are, first of all, the Dialog Manager. This is the class that manages all the interaction between the philosopher and yourself using the dialog box. Okay, by the way, you have this dialog box in here, which defines all the different UI components for creating this dialog box, basically. And then we have the Dialog Manager that controls all the interaction with the agentic backend. Okay, it will control the active philosopher, the one that you are talking to. Like for example, in this case, the active philosopher will be Searle, and also it's going to process the WebSocket message. Remember that in this project, we are going to interact. Phaser, the Phaser application, is going to interact with a fast API using the WebSockets protocol. All right, perfect. So apart from that, apart from the Dialog Manager, you can see here that it's processing the WebSocket messages, handle the default message in case there is not WebSocket return, etc. We also have inside services, this WebSocket API service. All right, and you can see here that it's going to connect with the localhost and port 8000, and this is exactly the point or the place where we are going to deploy. Let me show it here. We are going to deploy our fast API application. All right, you can see it's in localhost and port 8000. In fact, you can also access here the Swagger. Yeah, so here you have the fast API that the Phaser is going to interact with. All right, okay, so now that you have a very general grasp of what is happening, that is when I start talking with Searle, for example, a WebSocket connection is going to be established between Phaser and the fast API application, and we are going to send this Joe. All right. After that, what's going to happen is that this Joe is going to be received by the fast API application, and the fast API application is going to take care of taking the graph, the LangGraph workflow, and generating a response using this workflow. And after that, we are going to return the response using as well WebSockets. And this is exactly what you have here. I'm George Searle. Nice to meet you. I've spent years pondering the nature of understanding, etc., etc. All right. So now that you know how it works in terms of the UI, this WebSocket connection, this WebSocket API service, I'm going to show you what it looks like in terms of the agentic backend. All right. And to show you that, first of all, let's go into source Philo agents, infrastructure. Okay. Inside infrastructure, you will see this API.py. The API.py is going to define, first of all, this HTTP endpoint chat, and also this WebSocket chat. That's the one that we are going to use. And I'm not going to get into the details of this WebSocket syntax, but what I want you to check is this part over here, this get streaming response, because this is the function that is going to call the LangGraph workflow. All right. Previously, of course, we are defining some abstract classes, some internal domain classes that we need for the philosopher. Let me show it to you very quick. So we have this philosopher factory module that contains the relevant information we need to correctly impersonate with an agent the historical figure. All right. So let's take, for example, Turing. That's the one that we chat with at the beginning of the video. So we have Turing. Here we have like the philosopher name, the translation between the ID and the name. On Turing, then we have the philosopher style. What is the style that Turing is going to use when it connects, when it interacts with you? For example, Turing analyzes your idea with a puzzle solver's delight, turning philosophical AI questions into fascinating thought experiments. He'll introduce you to the concept of the Turing test. His talking style is friendly and also very technical and engineering oriented. All right, so this Turing's style, and also philosopher perspectives. The Turing's perspective about AI. Here, in this case, you can see Turing right here. So Alan Turing is a brilliant and pragmatic thinker who challenges you to consider what defines thinking itself. Proposing the famous Turing test to evaluate AI's true intelligence, he presses you to question whether machines can truly understand or if the behavior is just an imitation of human cognition. That's exactly what Turing asked us about, right? Perfect. So with all of this information, we are going to use the philosopher factory to create philosopher classes, philosopher objects, to be more precise, right? You can see here that we are creating this philosopher class, right? It's pretty simple. I mean, it's just a Pydantic base model that defines the ID, the name, the perspective, and the style. And all of this information is going to be encoded inside the character prompt. The prompt that we are going to use to emulate, to simulate the personality of each one of the philosophers. By the way, you have it here inside prompts. Okay, we are using OPIC, as you already see, for versioning each one of the prompts. We believe this is very good in terms of software engineering best practices, and this is something that many people overlook, but it's necessary to version all the prompts. I mean, here you have the philosopher character card. Okay, that's going to take the philosopher name, the perspective, the philosopher style, etc. And it's going to use this to create the system prompt for all the interactions with the philosopher. Okay, perfect. Right, so now that we know how this philosopher factory works, it's going to generate this philosopher object. All of this information is going to be passed to this get streaming response. It's going to use the LangGraph workflow to generate a response and return the response using the WebSocket protocol. You can see here, right? Like await, WebSocket send JSON, and then for each one of the chunks of the stream, we are going to send the response to the UI. That's exactly what we saw when Turing, also Searle, responded to us. Perfect. So let's continue and let's get inside the get streaming response. Inside here, you will see that first of all, we are defining the workflow graph. This is what we are going to look, but first of all, let me show you how this graph is going to be called. We are defining the checkpointer. Remember that we are checkpointing the LangGraph state inside MongoDB. This is what we call short-term memory in a fancy way, and we are going to cover that in a future lesson. We are going to cover both the long-term and the short-term memory, but just to let you know that this is basically it. I mean, we're just going to take the LangGraph state and we are going to persist this state inside MongoDB. All right, and that's why we need this checkpointer. After that, we are just compiling the graph using this graph builder compile with using the checkpointer, and then we are just using the OPIC tracer to get all the traces that we saw. Remember that if you go to comic OPIC, you will see here all these traces about the different chains and the different pipelines that are being called. Okay, after that, we are just defining the thread ID for the short-term memory. This is something that we will cover in future lessons, as I was saying. And lastly, we are just streaming the result using this LangGraph method for the graph stream, asynchronous stream. Okay, and we are passing all the relevant inputs for the graph computation. So now that you know how this is going to work, all of these chunks are going to be returned, remember, using this API, API WebSocket connection to the UI. Now that we know how this is going to work, it is time to see how the workflow, how the graph actually works, how it is implemented. And to do that, I'm not going to rely on the OPIC graph visualization. I'm going to do something that I believe is more easy to understand, and that is to use LangGraph Studio. All right. To do that, just verify that you have this LangGraph JSON in your version of the repository. This is something that I've just pushed a few hours ago, so just make sure that this is on your repo. And if this is on your repo, then you can simply install LangGraph Studio and just open LangGraph Studio inside the PhiloAgents API folder, all right, inside here. And if you do that, you will have something like this. This is the UI that will be open to you. And this is a very nice depiction of the LangGraph workflow that we are going to be using whenever we interact with whatever philosopher you want. So as always, when we use LangGraph, we have this start node. We need that because that's the node that indicates that the LangGraph workflow is going to start at that specific point. And then we are getting into this conversation node. So now we are going to be pivoting between this visualization and also the cursor code. because I think it's going to be easier for you to understand. So the conversation node, you can see here that the conversation node has two arrows, outbound arrows, right? One of them is going to link the conversation node with the retrieve philosopher context, and the other one is going to link the conversation node with the connector node. This connector node, by the way, is a dummy node. It's just going to allow us to connect, but it's transparent in terms of computation, right? It does not perform any kind of computation. Okay, but I will show you later in the code. So the conversation node is going then to connect using the connector node with both the summarize conversation node and also the end node, but it's also able to connect with a retrieve philosopher context. Of course, these dotted lines in the links in the edges signify that we are talking about a conditional edge. And what is the condition behind this conditional edge, you might be asking? It's basically the agentic RAG, because in this conversation node, the agent is going to decide, okay, do I need to fetch some relevant context and relevant data from the historical context? Remember that all of this data was fetched from Wikipedia and the Stanford Encyclopedia of Philosophy and was stored as embeddings, of course, inside MongoDB. That's the long-term memory that we are going to cover in future lessons. But yeah, as I was saying, this conversation node is going to decide, okay, do I need to get relevant embeddings, relevant context from that vector database from MongoDB? That's the retrieve philosopher context. Or should I just return a simple response? All right. In fact, if we go to OPIC again, you'll see here that we are receiving basically a normal response. I mean, we are not going to fetch any relevant information from MongoDB, because in that case, we will see that the agent is using a tool, the tool RAG, all right? But let me show you what happens if I ask Cheryl, for example, about the Chinese room argument. Can you give me relevant information about the Chinese room argument? And if we ask this, you will see that, if we go to comment again and we click this link, you will see here that there is something additional, something that didn't appear in the previous trace. That is the retrieve philosopher context. Our agent, NPC, is using a tool. It's using this tool to retrieve relevant context from the MongoDB long-term memory, okay? That's exactly why we needed agentic RAG, because when we said something so stupid as Cheryl didn't have the need to retrieve any relevant content from MongoDB. But when we ask about a specific information that we really want to know, in that case, the agent is going to say, okay, I really need to get this relevant context, this relevant information from the historical context that I have stored inside MongoDB. All right, and that's exactly why we need agentic RAG. Hope this is clear. If you have any additional questions or you want me to get into more detail in the future videos about agentic RAG, then just let me know in the comments. Okay, so that's basically the conversation node. And this pipeline over here is the agentic RAG. We are going to retrieve the philosopher context, like Cheryl has already done when he retrieved all the context from the Chinese room argument, and then we are going to summarize the context node. And this is because this is just for engineering, from an engineering perspective, from an engineering need. We needed something that compress a little bit the size, because otherwise you will waste a lot of tokens. So we needed a summarized version of the things that we were extracting from Stanford Wikipedia, Stanford Encyclopedia of Philosophy, or Wikipedia. And then the summarized context, of course, is going to be injected into the conversation node. And after that, with all of this information, the Philo agent will be able to give a response. All right, then we will get into this connector node. And after that, we are just going to either summarize the conversation node if it's too long, or just go into the end node. All right, so let's see everything in the code version. So let's get inside source Philo agents, application, and inside application, we are just going to get into this conversation service. By the way, I mentioned that in a previous video, but you can see that we are following some clean architecture principles here. We have the domain, this domain folder with all the different domain classes like the philosopher factory, exceptions, etc. Then we have the infrastructure, where we are defining, okay, the Mongo, all the Mongo implementations for the client, OPIC utils, the API, etc. And lastly, we have the application where we are defining all the use cases. In this case, I'm just going to show you the conversation service. That's the main use case for this application, but we also have additional use cases like this RAG, evaluation, etc. Okay, we are going to cover that in future videos because otherwise this will be too long. All right, so conversation service, and inside, if you get inside this workflow, you will see that we have a lot of LangGraph and LangChain related modules. I'm interested in this graph one and also in the state. So this create workflow graph is the method, I think it's pretty explicit in the naming, that it's going to create the graph builder. Okay, this graph builder is the object that we are going to compile. Remember that in the API we were just compiling the graph with all the checkpointers, etc. So this is exactly the object that we need. All right, we start by creating the state graph. Remember that we are dealing in LangGraph with graph with a state, and the state is this philosopher state. This is a custom state that we made that inherits from the messages state from LangGraph, and it contains additional attributes like the philosopher context, the philosopher name, philosopher perspective, the philosopher style, and a summary of the conversation so far. All right. After that, we are just defining all different nodes. We are defining the conversation node, the retrieve philosopher context, summarize conversation node, the context node, and the connector node. All of the nodes that you have in here. Perfect. So if we go individually to each one of them, so let's start with this conversation node. You will see that this conversation node is going to invoke a conversation chain. And if we go into this chains module, you will see that this get philosopher response chain is pretty straightforward. I mean, we are just getting the chat model. In this case, we are going to use Grok models, in particular Llama 3.3 70 billion. It's amazing that Grok is providing all of these LLMs for free. Then we are binding the tools. Okay, we are using these tools and binding the tools. And after that, we are just creating the chat prompt template using the different messages like the system message and this placeholder that takes all the history of messages of the philosopher and yourself. All right, and this is basically the get philosopher response chain. If we get back the conversation node, you will see that it's pretty straightforward. We are just generating a response using the conversation chain and just returning the response using this dictionary inside the messages. All right, so if we keep going, you will see here that we have the retrieve philosopher context. This is something that we are cover more in detail in future videos where we explain how the RAG system is implemented. But yeah, you can see here that the retriever node is going to be created with this primitive class from LangGraph tool node that is just going to take the tool. By the way, I think I didn't show you the tool, but it's just a retrieval tool that we created from the MongoDB instance. Okay, this is something that we are going to cover in future videos, by the way, so don't bother about it. But yeah, it's just going to take the tools that we have defined and to create one node for this tool. And this tool node, it's going to be basically the condition by which the agentic RAG is going to be triggered. Okay, so now if we go to the graph, you can see here that we have the retriever node, the one that we have just covered, and we are going to jump into the summarize conversation node. I'm going to be quick about this one because it's pretty trivial. We are just going to create, using this get conversation summary chain, a summary of the conversation so far. Okay, so let me show you very quick how this is going to work, but you have this get conversation summary chain. What's going to happen is that you're going to take the model, the Grok LLM model summary, by the way, in this case, is going to be a different one, different LLM than before, because we didn't need such a powerful model, such a powerful LLM for this. So we chose this Llama 3.1 8 billion instant, which is faster. So we thought it made sense to use this LLM in this specific case. Okay, so this get conversation summary chain, as I was saying, is going to take the Llama 3.1 8 billion parameters model. and it's just going to generate a summary of the conversation so far. All right, that's basically it. Okay, if we could move in, we can go into the summarize context node, and this is something very similar to the one we have covered before, to the summarize conversation node, only that in this case it's going to summarize the context, that is all the relevant information that you are taking from MongoDB. But it's pretty similar to the one we saw before. It's just going to use this get context summary chain, which is going to take a Grok model and just apply this context summary prompt. If you are curious, we have all the different prompts in here, inside the prompts module that is inside the domain folder, okay, because this is the domain of the application. Okay, and now let's go into the last node, which is the most stupid one. It's the connector node that does exactly this. That is, it does nothing, because it's just a transparent node that is able to connect between different nodes. Okay, so no big mysteries about this node, right? Okay, so let's go into the graph again and let's define the flow. This is important because we have isolated nodes right now, and now we need to define the different edges that are going to link the nodes. All right, so first of all, let's add the edge, the traditional edge, normal edge between the start and the conversation node. All right, then we need to add a conditional edge that is going to connect the conversation node and the retrieve philosopher context or the connector node. All right, and we are passing this tools condition, which is one class defined in LangGraph prebuild. All right, this is basically all the magic behind Agentic RAG. With this connection, with this conditional edge, we are defining Agentic RAG in just, I don't know, 5 lines of code. The agent or the conversational node is going to decide if the retrieval phase is necessary, is needed for the specific question. Okay, and if it's not, then it's just going to get into the connector node. If it's necessary, it's going to get into the retrieve philosopher context, retrieving all the content using the tool. Right? Perfect. Then we need to add an edge between the retrieve philosopher context and the summarize context node. Remember that we needed this to compress a little bit the information. Then we are adding an additional edge between the summarize context node and the conversation node. Okay, remember that we weren't doing that exactly here. Summarize context node and the conversation node. Okay, so we are injecting all of the relevant information into the conversation node. And the conversation node will ask again, okay, with all of this information, am I prepared to respond something useful to the user, or do I need to fetch relevant information from MongoDB again? All right, because you can see here that we are defining a loop between this node, and this node. There's a clear loop: conversation node, retrieve philosopher context, summarize context node, and conversation node. All right, perfect. After that, we are defining another conditional edge between the connector node and should summarize conversation. And this is the condition that we are defining for this conditional edge. If the length of the messages is superior to this total messages trigger, that let me refresh what was the number. So yeah, it was 30 messages. Okay, so after 15 interactions, 30 total messages, this node is going to be triggered. The summarize conversation node is going to be triggered because the should summarize conversation condition will be true. All right, perfect. And lastly, we need to add another edge, additional edge between the summarize conversation node and the end, because otherwise it will never end the workflow, right? Okay, and this is exactly what we are going to return, this graph builder. All right, so you can see that the graph at the end of the day is pretty simple, I believe. I mean, we have just 1, 2, 3, 4, 5 nodes, and one of them is completely stupid. So you can see how with this simple graph, we are defining a lot of things, because we are defining tools, we are defining Agentic RAG, and we are defining some clever workflow that allows us to impersonate, that allows us to create NPCs that are intelligent, that are impersonating historical figures. And I think that's amazing. And this, my friends, is everything for today. So now that you understand how this Landgraf workflow works, now that you understand how the brain of each one of the philosophers really works, I would encourage you to take a walk around the village, to start talking to the different philosophers, to try to convince Aristotle that he was wrong, or try to convince Descartes that world is indeed materialistic. Play around with the Landgraf workflow, try to improve it, try to come up with ideas, try to come up with new ways of doing the same thing. Maybe you want to add some additional tool, maybe you want to create an additional character, an additional philo agent. I would encourage you to try to do all of these things, because I strongly believe that that's the only way for you to understand. Of course, you could simply follow this video, that's perfectly fine, but I think that if you really want to understand, it will be much better if you start doing, playing with the code behind this. It will be a very, very cool experience. And of course, you can share all of these new features, improvements, or even suggestions with us, with LinkedIn, Substack, or here on YouTube. Alright, so that's everything for today. I hope you have enjoyed this video. I hope you have learned something useful about Landgraf, and also that you are having a good time, a fun time playing with this Philo Agents simulation. Alright, so as always, it's been an immense pleasure, and I'll see you next time. Until then, happy coding, and I guess happy philosophizing. Bye bye.